Okay, here's a quick review of quadratic functions. Quadratic functions are usually written in one of two ways. The way it's defined, y equals ax squared plus bx plus c, all right? Or in this form, which is referred to as standard form, we used to call it vertex form, y equals a times the quantity x minus h quantity squared plus k. Now this a and this a are the same. If you have it in this form and they ask you to find the vertex, you've got to use this approach. This will give you the x value of the vertex, and then once you have this number, whatever it might be, then you can plug in for x and find the y that goes with. But this is even nicer, because if it's in this form, you can see what the vertex is right away. It's the h here. Now notice the minus sign in front of the h. It's kind of the opposite of what it looks like. And then the k on the outside here, and that's exactly how it looks like. So if I said, for example, what's the vertex of this function? You could say, well, this is in this form here. All right, there's no number written out in front like an a, but that would be an understood 1, and there's no k written out there, but that would be like an understood 0. So what happens here is your vertex is, now notice here, the plus 4, it's got to be in the form x minus the number. Plus 4 is like minus a negative 4, so it's kind of the opposite of what it looks like inside the parentheses, exactly what it looks like on the outside. And we also know that because a is 1, that it opens upward. You say, well, how do you know when it opens upward? Well, when a is positive, it opens upward. If a is negative, it opens downward, like inverted. An upward, regular looking U, excuse me, and a is less than 0, it's downward, like an inverted U, an upside down U. Okay, look over here. You say, well, wait a minute, this doesn't look like either one of them. Well, it would if I changed the order around here and wrote this as the opposite of x squared plus 3. Now this looks like it's in this form because there's no parentheses. But technically, you could think of this as parentheses. You could think of this as the opposite of x minus 0 quantity squared plus 3. And then you can see that your vertex, I'm just going to write a V for vertex, is going to be 0, positive 3. And because the number in front, a, is a negative 1, it opens downward. So if they gave you, let's say, for example, these are problems 2 and 4 out of your book from section 2.1. If they gave you graphs, and it was like multiple choice, just using this, these 2 bits of information, you could figure out which one your graph is. Now, the next kind of problem is kind of like problems 9, 10, 11, and 12, and they're all starting with the parent function, y equals x squared. Now, the y equals x squared, that's your parent function, and the graph, this is going to be kind of sloppy, because I'm doing this quickly in freehand, which I should never do. The vertex is at 0, 0, and it opens upward. And it's kind of a U shape like this. Now what happens here, in these examples, these are transformations that have been performed on y equals x squared and would give you a different looking graph. It might be inverted, it might be translated or shifted, it might be stretched or compressed, all depending on that type of transformation. Those are the transformations you've been studying. So like here, if you look at answer A, how is this related to this? The plus 1 moves it up 1. So it shifts upward 1 unit. Now notice here, the plus 1 is on the outside. Here I've got a minus 1, x minus 1, and that shifts. This is, when you have the numbers on the outside being added or subtracted, it shifts it vertically. But when you have the numbers like here in E and F, in the parentheses, it shifts it horizontally. So this would actually go, shifts to the right 1 unit. And you say, well, why is it to the right? It's a minus 1. For the same reason that it's always kind of the opposite of what it looks like inside the parentheses. That's how it's going to tell you, because you'd have to plug in a bigger number here, then to subtract the 1 to get the number you were actually wanting. So that's going to have to be shifted to the right. Whereas this one, the +3, this is going to shift to the left. Now again, you have to be looking at this to see that it's inside the parentheses. That's being added or subtracted exactly from the x, not from the x squared. Shifts to the left 3 units. Over here, this one is shifting downward 1 unit. I'm not going to write it out, but you can see if this one goes up 1, this one goes up 3. Shifts it, vertically shifts it or translates it 3 units upward. Vertically shifts it or translates it, this one here, 3 units downward. Now, when you have a number in front of the x squared that's being multiplied times it, this is when you have a what we call a dilation or a stretching or shrinking. If the number, the a here, by the way, here a is positive, here a is negative, opens upward, opens downward, right? What happens here is if this number a is between 0 and 1, it shrinks it, it compresses. Whereas if a is greater than 1, it stretches it vertically. These are verticals, stretching and shrinking, stretching and compressing, right? So this one is between, here, actually I'll put absolute value of a. This one here is 1/2, that's between 0 and 1, so this would be compressed or shrunk by a factor of the denominator there, by a factor of 2. And whereas this one, there's a negative in front, that's going to be a reflection in the x-axis. This one is also going to be stretched because the absolute value of a here is greater than 1. It's going to be stretched by a factor of 3, but it is going to be reflected because of the negative there in the x-axis. So I'm going to write that down, reflected in x-axis. Okay, as well as stretched by a factor, vertically by a factor of 3. All right, now I kind of threw a couple things in on this one. In this one, you can see there's a 2 being subtracted from the x. There's a +1 on the outside. Those are the translations. There's a 1/2 in front, kind of like the 1/2 in front here. So that's going to be a compression or shrinking it. So for I, it's going to shift 2 here. I'll just write it out. 2 to the right. It's going to compress or shrink by a factor of 2. And it's also going to shift upward 1 unit. Okay? This one is a little bit of everything that's kind of different. This is negative, this is, change sign, change sign. So it's just going to kind of all be kind of the opposite as far as the shifting. This one is going to shift horizontally 2 units to the left. Okay, this negative is going to reflect in the x-axis, and it's also going to shrink it, so it's going to compress or shrink. I'll list them here. Vertically by a factor of 2. It's also going to reflect it in the x-axis. And then it's also going to shift vertically 1 unit, the -1 there, downward. I can't imagine you'll have anything messier than that. And that has 4 actual transformations that are being done on that. Now, worst case scenario, identify the vertex like we were up here, and then use that to set up a t-chart. And if you have time, make a quick sketch. That'll help to explain what's going on. We'll do a sketch here in just a minute. Well, that minute's over with. Here, we're going to do a sketch. It says, sketch the graph, identify the vertex and the intercepts, the x-intercepts and the y-intercepts. So first things first, I identify the vertex before I try to graph anything. My vertex See, it's in the standard form, x minus h, and then the plus k on the outside. So my standard form is vertex is 6, 3. I'll make a t-chart here, x and y, and I'll make 5 points. I'll put 6, 3 here in the middle. I don't need all that, I guess. So I'll go 1 bigger, 1 smaller, 2 bigger, 2 smaller. And that way, you know, those will match and those will match. So if I take 7 and plug 7 in, 7 minus 6 is 1, 1 squared is 1, plus 3 is 4. So this will be a 4. If I put 8 in here, 8 minus 6 is 2, 2 squared is 4, plus 3 is 7. So I can see that this graph looks like it's going to open upward because A is a positive 1. And its vertex is in the first quadrant. So I'm thinking most of the graph that I'm going to be able to draw here is going to be in the first quadrant. So I'll make this nice and big. I'm going to go by ones here. Think you can see that okay? So I'm going to graph the point 4, 1, 2, 3, 4, 5, 6, 7. 5, 4, 1, 2, 3, 4. 6, 3, that's my vertex. 7, 4, 8, 7. You can see the U shape. Be careful sketching them. Don't get in too much of a hurry, and be careful with your signs. When you're doing your arithmetic, I guess I can make that a little bit taller to kind of match up with it. And that's how you graph that one. Now, you say, well, what about my intercepts? Well, there are no x-intercepts. You can tell that. Do you remember how to find an x-intercept? You set this whole thing, you make y or f of x equal to 0, set this whole thing equal to 0, and then you solve for x. And in this case, if you did, it wouldn't factor, you'd have to use the quadratic formula, and you'd get an imaginary number. You get two imaginary numbers. But there's always a y-intercept. Even if it opens upward or downward, there's always a y-intercept. You set the x equal to 0, f of 0 equals 0 minus 6 squared plus 3. 0 minus 6 is negative 6 squared is 36 plus 3 is 39. So it has a y-intercept at 0, 39. Clearly not going to be on my graph. I didn't make my axes long enough for that. I don't know if they're going to ask for the intercepts. But remember, to find x-intercepts, you make y equal to 0, you solve for x. To find y-intercepts, you make x equal to 0 and solve. But that's how I graphed this. I really like the fact that it was in vertex form so I could find the vertex right away. This one is not in vertex form. As you can see here, A is negative 1, B is negative 4, and C is 1. This is just how quadratic functions defined. So remember, you have to use the x equals the opposite of B, so this would be the opposite of negative 4 all over 2 times A, which is a negative 1. So I get 4 over negative 2, which is negative 2. My vertex is negative 2 something. To find the something, take the negative 2, plug it back in here. We'll look out for those negatives. So if I plug negative 2 in, I get y equals the opposite of negative 2 squared minus 4 times negative 2 plus 1. So negative 2 squared is positive 4, and the opposite of that is negative 4, plus 8 plus 1 is 5. So my vertex is negative 2, 5. A is negative, so it opens downward. Let's see if I can get this one in here. I think I'll just freehand this one because I'm hurting for time. Let's see, negative 2, 5, probably about like this. So we'll make that worth 1, that worth 1. Negative 2, 5, 1, 2, 3, 4, 5. So I make a t-chart, x, y. And I'm going to put it as my 1, 2, 3. I'm going to put my vertex here, negative 2, 5. So 1 bigger, 1 smaller, 2 bigger, 2 smaller. That way these match, oops, and these match. Well, let's plug negative 1 in. Negative 1, I have to plug it in here. So that'd be negative 1 squared is 1. That'd be the opposite of that. It'd be negative 1 plus 4, because I'm going to have a negative times negative. So plus 1 would be 4. So this one's 4, this one's 4. 0's nice. Plug 0 in and I get 1 and a 1. So now I graph negative 4, 1, negative 3, negative, or positive 4, negative 1, positive 4, and 0, 1. There you go. You can see it's inverted. Now, the y-intercept's easy because we already have it. We knew it was going to go through 0, 1. But the x-intercepts would be a little tougher. You would have to set this equal to 0. And I didn't give myself hardly any space here. I would probably multiply through by negative 1 just to get rid of a couple of these negatives. X squared plus 4x minus 1. It does not factor. You're going to have to use the quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac over 2a. Let's see, that'd be negative 4 plus or minus the 16 minus 4 times 1 times negative 1. Excuse me. So that's going to be negative 4, 20 all over 2. Square root of 20 simplifies to 2 square roots of 5 divided by 2. 2 goes into both, so that's going to be negative 2 plus or minus the square root of 5. And those would be the x-intercepts. Once again, I don't know if he's going to ask for the x-intercepts. I don't think he really spent much time doing that, to my knowledge, in the assignment. All right, almost done. My throat's starting to go here, so it's good that I'm almost done. Okay, find the quadratic function described. Well, they give you the vertex. Once you know the vertex, you go right back to this guy. Standard form. But memorize that and plug this in for h and this in for k. X minus h would be x minus a negative 2 would be x plus 2 quantity squared minus 1. I got to know what a is, so they give me one extra point. Plug that in for x and y. Did you hear me? Put the vertex in for h and k, rewrite it, solve for a by taking the point that the second point that's given, plug it in for x and y, so this would be 3 equals a times the quantity 0 plus 2 quantity squared minus 1. 0 plus 2 is 2, squared is 4, so this is 4a minus 1. Add 1 to both sides. I get 4 equals 4a. I get a is equal to 1 if I divide both sides. So I'm going to put the 1 right there, which means I'm really not going to put the 1 there. I'm just going to write it out. Y equals the quantity x plus 2 quantity squared minus 1. If you put the 1 there, you might take a point off because it's not simplified. Same idea here. Only this time I didn't give you the graph, but I gave you enough information to figure this out. So again, write to this guy. Now if he says write the equation, write it with a y. If he says write the function, don't write it with a y, write it with like f of x or g of x. So in this case, no, it says find the quadratic function. Okay, guess I should follow my own directions. All right, here. So this is I'm going to use f of x here. All right. So now I'm going to plug the 2 and 3 in for the h and the k. I get f of x equals a times x minus 2 quantity squared plus 3. All right, then use the point 0, 2. So f of x is 2. So that's my y. A times 0 minus 2 quantity squared plus 3. 0 minus 2 is negative 2. Negative 2, oh, hang on a second. Yeah, negative 2 squared is 4. So this is 4a plus 3. And then I'm going to subtract 3 from both sides. And I get negative 1 equals 4a. And then I'm going to divide by 4. And I'm going to get a is equal to negative 1/4. So that goes right there. I'll put it here. F of x equals negative 1/4 times the quantity x minus 2 quantity squared plus 3. So we just plugged negative 1/4 in there for the a. I would imagine you'll probably have to do these. He had you do enough of those in your daily assignment, the one from, I think, from Friday, that it's probably would behoove you to know this. By the way, 38 and 42, just like back here, 18 and 24, those are problems out of your book. out of section 2.1. All right. Now there's only a couple other things that are left that I saw, and one of them was a story problem, and I know you weren't too crazy about those. But the other one is they give you, actually, it would help if I wrote down what the intercepts were here. So for 57, the intercepts are -1, 0, and 3, 0. Now if you were to graph this, and you don't have to, but if you were going to graph this, I want you to think about what the intercepts mean with a graph that has symmetry like it does. Has symmetry to a vertical line. Remember the axis is symmetry? -1, 0, and 3, 0. You have symmetry whether it opens upward or whether it opens downward. So in this case, we're to find 2. I think when you were looking at this the first time, you maybe only found one of them. But you were to find 2 quadratic functions, one that opens upward, one that opens downward. Okay? If it opens upward, you just have to make sure A is positive. So you need to know a little bit about where the vertex is at. Well, the x value of the vertex is on this vertical line somewhere that's exactly in between, like the perpendicular bisector of this line segment whose endpoints are the intercepts. So you just average them. If you add 3 and -1 and divide by 2, you get 1. So we know that the x value of the vertex is 1 something. So what I'm going to do is I'm going to go to this. I'm going to write f of x equals a times the quantity x minus h, quantity squared plus k, and I'm going to plug 1 right in there. So I have f of x is equal to a times the quantity x minus 1 quantity squared plus k. Now I have to figure out what k is, and I have to figure out what a is. Now it says that it opens upward, so I can pick a value for a as long as it opens upward, a is positive. So I would probably pick something easy, like 1 or 2. So if I put 1 in here, then I have f of x is equal to 1 times x minus 1 quantity squared plus k, and I don't even really need the 1. To find k, I take either one of the 2 intercepts, and I'm going to take 3, 0 since it's positive, 0 in for y, 3 in for x. 0 in for y, 3 in for x. This is going to be 4. So that means if I subtract 4 from both sides, I get k is equal to -4. So I can put a -4 right there. And I have my first one. To get the second one, instead of a positive 1, I'll do this all over again. But this time, I'm going to plug in a -1. And all this part still stays the same. I just need it to open downward, so I pick a nice simple negative number like -1. Now you don't have to actually put the 1 there, the opposite sign's good enough. And again, I pick a point that's not on there because I got to find out what k is. So maybe I'll take 3, 0 again. So 0 in for f of x or y, and 3 right here. So this is going to be 2 squared, which is 4. So this is going to be -4 plus k, or k is equal to a positive 4 if I add 4 to both sides. Alright, so k is positive 4, it goes right there. I probably won't put the -1, I'll just write the negative sign. F of x is equal to the opposite of the quantity x minus 1 quantity squared plus k, so plus 4. And there's 2 good equations there. That'll work. Now I hope that he doesn't have anything quite that messy, but if you practice a couple of these, you're going to be fine. Same thing goes with 64, which is a maximizing problem. It says here, find 2 positive real numbers whose product is a maximum. All right, so let's say I have 2 positive real numbers. I have x is greater than 0, and I have y is greater than 0. And they're going to be positive real numbers. And I'm going to try to maximize the product. So the product would be, when you multiply, would be x times y. But I don't want 2 different variables. I need to somehow eliminate one variable. I need to find like a secondary equation so that I can make a substitution into this. Because this is what I'm maximizing. So this is what I'm going to be finding the vertex. Because I'm hoping to find a parabola that opens downward, whose vertex is at the top of the hill. And that means it has the maximum y value. Well, p value in this case. But what I'm going to do here is use the second sentence. It says the sum of the first number, so let's say x is the first positive number, y is the second positive number. The sum of the first and 3 times the second, so I add to it 3 times y is 42. So now I'm going to, usually I solve for y, but I'll have a fraction, so I'm going to solve for x. And I'm going to subtract 3y from both sides. And I have x is equal to 42 minus 3y. And I'm going to substitute that in to this equation right in here for x. So I have a function of y actually, it's kind of weird. It's going to be 42 minus 3y times y, or 42y minus 3y squared, or negative 3y squared plus 42y. You can see that this is in the form of a definition. They don't have this where they've completed the square. We need to complete a square yet before this is all over with also. So we'll do that here in just a second. I can find another sheet of paper. So in this case, A is negative 3 and B is 42. I need the vertex, so I'm going to use, well, in this case, actually, it's not x equals, it's y equals, because my variable is y. The opposite of B all over 2 times A, so that's negative 42 over negative 6, that's positive 7. So if that's positive 7, then I need the, find 2 positive numbers. Well, I've got one of them. Now I've got to plug the 7 in here and solve for the other one. X equals 42 minus 3 times 7, 42 minus 21, or 21. So the two numbers, it's a story problem. Write out your answer in a short sentence, are 7 and 21. And that's what would the product be? 147 would give me the maximum product. All right, now let's not forget about completing the square. You must develop a flare to complete the square. Let's start with something easy. Y equals x squared plus 4x minus 3. And let's say we're going to rewrite this and put this into standard form by completing the square for the x's here. So what I'm going to do, first things first, the coefficient of the x squared, the number in front of the x squared has to be a 1, and it is. So I'm going to write the two terms with the variable right next to one another. I'm going to put a little bit of a space, and I'm going to write the minus 3. You go to this now, you take half that number, which is a positive 2, and square it, and that's a positive 4. Since I added 4, that's what I've added here, there's nothing times it. If I add 4, then I also have to subtract 4 from the same side. So that's going to give me y equals, now this is a perfect square trinomial. I'm going to write it as a perfect square trinomial, binomial squared, and the minus 3 minus 4 is minus 7. So this is an x, whatever's being squared here, whatever's being squared here, that's a 2, and whatever the sign in front of the middle term is goes right there. So I can tell you that my vertex for this parabola would be negative 2, negative 7, and I've completed the square. Here's another one. Let's see. Okay, this time my lead coefficient for the x squared is not a 1. So if that's the case, you take the two terms with the variable and you factor this out, even if you end up with a fraction. So I'm going to have to factor out a 2, and fortunately for me, 2 divides into 12 6 times. I'm going to leave a little bit of a space, but the plus 5 on the outside. I don't want to factor the 2 out of the term, the constant term. So I take half of this, which would be negative 3, and I square it, and that'd be a positive 9. But I didn't add 9. Because this 9 inside the parentheses gets multiplied by 2, I added 2 times 9, which is 18. So I have to subtract 18 from the same side here. So this becomes 2 times a quantity squared, and that becomes a minus 13. This will be an x, this will be a 3, whatever's being squared here, whatever's being squared here, and the sign in front of the middle term. So I can tell you that my vertex is 3, negative 13, and I can also see it's being stretched vertically because of that 2 right there. It opens upward. So I hope that helps a little bit, get you ready for it. Practice the problems, practice all the odd number problems, and check your answers. And then if you have any questions, give me a call. Good luck with this now.